So when you're developing a new product, I mean, whether it's a high-end luxury piece or, a fast fashion staple, the risk is always the same.
It is. You're committing capital, time, materials,
Mm,
all to a concept that might just fail to capture the moment.
exactly. We're talking about that huge, expensive hurdle of creative validation. You have a vision, a sketch, maybe a beautiful CAD image, but is it actually viable?
And can you prove it with data, not just a gut feeling before you push it to production?
Right.
That tension, between the creative spark and commercial viability, that's the crucible of the entire design industry.
It really is.
And today, we are deep diving into how AI is promising to resolve that very tension by providing these immediate data-backed proof points.
We're looking at a specific tool, right? The F-Trends Design Viability Check.
We are. Our mission for you is to understand the exact mechanics of this system. We're going to map out the entire workflow step by step, focusing on how a raw creative idea gets metabolized into actionable, risk-reducing data.
So this isn't just a manual read-through. We're dissecting the core mechanism. The tool claims it evaluates concepts based on what we're calling the critical triumvirate of design.
Color, pattern, and silhouette.
Precisely. We need to see exactly how it judges the interplay between those three things and, what that actually means for you as a designer.
It's about synthesis, not just analysis, and that's what makes this system so interesting. It doesn't just look at trend data. It uses that data to offer prescriptive guidance.
Okay, so let's start at the very beginning, the input phase.
An entry point.
Right. What I find interesting here right off the bat is the low barrier to entry. What kind of file or format does the system require to get this whole validation process started?
Well, the input requirements are remarkably flexible, which is, I think, a key factor in making this a tool for rapid iteration, not just some final stage check.
So you don't need a perfect render.
Not at all. You can upload anything from a rudimentary hand-drawn sketch, maybe just a quick concept idea, to a highly detailed CAD rendering.
What about a physical sample?
Oh, absolutely. A photograph of a physical sample that you're thinking about adapting or maybe refreshing. The underlying AI engine just handles the visual recognition, regardless of the image quality.
That flexibility is so crucial. It lets a designer validate a concept much, much earlier in the cycle.
Exactly. If you can test a sketch for viability, you save thousands of dollars on prototyping a concept that was, well, maybe always going to fail.
So once that visual input is loaded, the user has to define the context for the analysis. Why is this configuration step so critical?
This is where the AI gets its marching orders. It's what turns general trend data into highly specific, usable market intelligence.
So you have to select certain parameters.
Several crucial ones, yes. You have to define the target market. Are we looking at mass market or luxury? The specific season, the geographical region.
Gender segment, I'm assuming.
Gender and the specific forecast duration. Without that filter, the system would just return this huge blob of global trend data.
Which is functionally useless if you're targeting, say, high-end menswear in Seoul for autumn-winter 2025.
Precisely. You're essentially creating an analytical sandbox for the AI. You're telling it which competitor sets to benchmark against, which consumer demographics to consider, and which past performance indicators are even relevant.
It's all about targeting.
It's the first step in mitigating that data overload that plagues traditional forecasting.
And there's a neat little utility detail here for users who are doing this kind of validation regularly.
Yes, a good workflow refinement we should mention. If you are logged into the F-Trends platform, your analysis results are automatically archived.
They're saved to your portfolio.
Right. And this lets designers and product managers keep a sort of a chronological history of their concept tests. They can track which elements they modified to move a concept from low viability to high viability over time.
That's smart research hygiene built right into the platform. Okay, so we've uploaded the concept, we've custom configured the market parameters, the sandbox is set. Now what?
Now we move into the actual analysis, the engine room. The user clicks Analyze Design Viability.
And this is where the magic happens.
This is the moment the latent space modeling kicks off. The key function of the AI here is to evaluate the design based on the synergy of those three elements we keep mentioning.
Color, pattern, and silhouette.
And what's fascinating is that the system doesn't analyze them independently.
Okay, explain that difference for us. Why is a combination so much more powerful than just looking at color trends and silhouette trends separately?
Because fashion success is often, well, it's nonlinear. In traditional trend forecasting, a team might spend weeks confirming that, for example, relaxed fit denim is trending. That's silhouette.
And separately, they might confirm that electric violet is an emerging color.
Right. But if you combine them, an electric violet relaxed fit denim jacket with a bold abstract floral pattern, that specific intersection might hit a high growth curve.
Or it might be a catastrophic miss.
It might be, because the consumer reacts to the full composition, not just the isolated parts.
The combination creates unique aesthetic fingerprint.
Exactly. And the AI is designed to look at millions of competitive retail data points, sales figures, SKU performance, social media sentiment, runway adoption rates, to judge where that specific combination is currently positioned in the market life cycle.
So saturation, peak, growth, decline.
All of it.
That level of computational complexity, it must require a pretty significant processing window. If you're dealing with millions of data points, how long does this synthesis actually take?
And here is the factor that is truly disruptive to the traditional design cycle. The entire processing phase, from clicking Analyze to the comprehensive results being ready on your dashboard, takes only 70 to 80 seconds.
70 to 80 seconds. Okay, now, for you listening, trying to grasp the scale of this, it sounds almost too fast.
I know.
Does that speed mean we're sacrificing depth or accuracy? How can a system ingest and synthesize all of that data in such a compressed time frame?
That is the critical question. Yeah. The speed doesn't come from limiting the data. It comes from parallel processing and the pre-categorization of the trend data lake.
So it's always working in the background.
Constantly. The F-Trend system is always scraping, cleaning, indexing the data SKU performance from thousands of retailers, localized sales info, image recognition from social platforms.
I see. So when you upload your design, the AI isn't starting from scratch.
Not at all. It's deploying highly optimized algorithms to query that massive pre-indexed lake against your specific combination of color, pattern, and silhouette, and the market parameters you just selected.
So the heavy lifting of data prep is constant. The analysis itself is just a rapid-fire comparative modeling exercise.
And that compressed research cycle fundamentally changes design lead times. It enables what we call micro-iteration.
Meaning you can test multiple versions quickly.
Designers can upload multiple, slightly different versions of the same concept. A variation on the pattern, a tweak to the color saturation, a tiny hemline adjustment, and validate all of them in the time it used to take to just schedule a meeting to discuss one.
Moving fast is one thing. Getting actionable results is another. So let's look at the next part. The initial results dashboard. After those 70 seconds, what's the first thing you see?
You immediately get a comprehensive color palette analysis. And what elevates this beyond just a simple trend report is the categorization.
How so?
This color analysis is broken down specifically by garment type.
Oh, that detail matters immensely.
It absolutely does. A vibrant cerulean might be peaking in accessory trends, but it might be totally saturating the market for, say, core knitwear.
And the system stops you from making that expensive mistake.
It shows you exactly where that specific shade is strongest, and it goes beyond just prediction. It offers creative guidance right there on the screen.
I see it displays suggested color harmonies.
Yes, and that's where the system provides immediate value for that work with your analyzed design.
So it takes that one validated piece and immediately gives you the color DNA for the rest of the collection.
It saves days of palette selection and testing, but the real insight, the one that delivers that granular, predictive knowledge, that's the drill-down capability.
Right. We're not just talking about general color families anymore.
We're talking specific shades. If you, the user, click on any of the Pantone colors displayed on that dashboard, you access the deep data layer.
And what does that look like?
That click generates specific performance graphs, detailed forecasts, and predictive trend lines for that exact shade, not the general hue.
This moves us entirely out of the realm of subjective trend reporting. You're not just being told that green is rising.
No. You're getting a minute-by-minute snapshot of how forest green 1960-26 is predicted to perform against competing shades in the luxury outerwear category.
In the specific region and for the specific forecast period you set up at the beginning.
Exactly. It gives the designer a quantifiable metric of risk and potential return linked to the product's exact shade. This is where you gain that decisive competitive edge.
By turning broad trend data into a pinpointed investment strategy. Okay. So we've validated the color, we've seen its potential performance down to the Pantone level, but we still need to bring pattern and silhouette into this detailed analysis.
Correct.